All right, let's look at the homework 8, problem number 25. All right, so a candy box is made from a piece of cardboard, 11 by 7 inches. Then we take the squares away from corners to make a box. All right, so it's gonna look like that. All right, so you have a 11 by 7, 11 by 7. Then you take away 4 squares off the corners, and then lift the walls up to make an open box like that. Right? So dimension of the box would be, obviously the height is going to be the x, and since you take away x's from 7, so you have a 7 minus 2x, and the other side is going to be 11 minus 2x, right? So if you find the volume of that, and volume is actually fairly simple, so volume is going to be, right, so it's going to be 11 minus 2x times 7 minus 2x times x. So you have 11 minus 2x times 7 minus 2x and times x, right? I think I'm going to just go ahead and multiply out. So this is going to be 11 times, so I'm going to just distribute the 11 to 7 and negative 2x, right? So we're going to get 77, right, minus 22x. All right, then I'm going to distribute negative 2x to 7 and the negative 2x. So it's going to be negative 14x and plus 4x squared, right? So if you clean it, oh, actually, then you have to actually multiply by x, right? So you still have x there. All right, so let's clean this up, all right? All right, so we have, let's see, we have a 4x squared and times x. So I'm going to put the 4x cubed. Right, so I'm going to distribute the x to this guy, right, and then distribute x to those two x terms. So this is going to be negative 36x times x. So it's going to be negative 36x squared. Right, then the last one is x is distributed to 77, so it's going to be plus 77x, right? So that's the volume function, right? So let's find the critical number. So we take the derivative of the volume function with respect to x, so here. All right, so it's going to be 12x squared minus 72x plus 77. All right, so we set this guy equal to 0, and this does not factor out nicely, so we have to use a quadratic formula. So x is going to be equal to, all right, negative b, so it's going to be 72 plus or minus square root of 72 squared minus 4 times a is 12 times c is 77. So numbers are pretty bad. Over 2 times a is 12. Alright, so let's compute this. So you have a couple of values we can get. So I'm going to open up GeoGebra here. Alright, let's compute. So this is going to be 72. Let's do the minus one. Minus square root of 72 squared minus 4 times 12 times 77 and divided by 2 times 12, so 24. Right, hit enter. So it came to be about the 1.39. So this is about the 1.39. Right, I think this is approximation, so I'm gonna just use the so this is gonna be approximately. All right, and let's do the positive version. Positive version is going to be, I'm gonna just open this up. Let's see. All right, oh, I can't see it, so I'm gonna just make it a little bit larger. All right, so since I just want to change that to a positive sign here, so I'm gonna do a plus. All right, then see what happens. All right, it came out to be 4.61. 4.61. All right, but remember that the one side is only 7 inches. We cannot take, more than 3.5 inches. So in this case, 4.61 is not reasonable. So I'm going to eliminate that. All right, so only critical number is 1.39. All right, then since this is a parabola, right? So I kind of see the ballpark shape. So the derivative is a parabola, so it's going to have some shape, and it's a facing up. And you can see that this point is a 1.39, and this point is about 4.61. So you can see that the derivative is positive before 0.39 and the negative after 1.39, which means that you're going to have a maximum here, right? So I think we know the answer is a length, let's see, a square with a side length is going to be 1.39 inches, right? Cut off, right? So check the answer, right? We got that. All right, that's it. I hope that this was clear.